Good morning, dear students. So last class we learned how to write a chemical formula using symbols and valencies of different radicals. So today we will be learning how to write a balanced chemical equation. So before writing a balanced chemical equation, first of all, let's see what is a chemical equation. And before starting chemical equation, let me ask you, what is an equation? What is an equation? An equation is the statement which proves that left hand side is equal to right hand side, especially in mathematics. In mathematics, what is an equation? An equation is a statement which shows that left hand side is equal to right hand side. But here in chemistry, we will not write that left hand side is equal to right hand side. But here also number of atoms of different elements present on the left hand side must be equal to number of atoms of different elements present on the right hand side. That means no new atom can come to the right hand side if it is not there in the left hand side. So that's why it is also called equation, and chemical equation because it is related with chemical reaction. It is related with chemical reaction. So what is a chemical equation then? A chemical equation is the symbolic representation of a chemical reaction. So chemical reaction, say for example, oxygen plus hydrogen gives water. Oxygen plus hydrogen gives water, and some of the reactions are very lengthy, very long if we write in word. But how can we write them in a very short and appropriate way? So in order to write a very lengthy chemical reaction in a very wise, understandable manner and in a short and precise way, we use symbols. We use symbols and chemical formula for writing this word chemical reaction, and that is chemical equation. So in short, if I have to say, then a chemical equation is short representation of a chemical reaction, is a symbolic representation of a chemical reaction. So what is chemical equation? Symbolic representation of a chemical reaction. So in this chemical equation, what are the things we will be using is symbols and formulae. Symbols and formulae of the substances involved in the reaction. So whatever symbols and whatever formulae are involved in the chemical reaction, that what we use to write chemical equation. Okay, then the substances which are reacting to give a product. The substances which are reacting to give a product are said to be reactants. And the substance that is formed as a result of this chemical reaction, the substance that is formed as a result of chemical reaction are products. So reactants are those substances which undergoes a chemical reaction, okay, and product are the substances which are formed as a result of a chemical reaction. So reactant is something which is acting, and product is the result. So reactants, products. Reactants reacts to give products. Reactant reacts to give products. This reactant reacts to give products. So in maths, instead of this we put equal to sign. But in chemistry we put arrow. In place of equal to we put arrow. So example, carbon. plus oxygen. Carbon plus oxygen on heating gives carbon dioxide. Whenever we burn wood or charcoal, we get a gas. We get a gas, and that gas is carbon dioxide. So this is something, means we are writing this reaction in the form of word. In the form of word. So this is not chemical equation. This is not chemical equation. This is word equation. This is word equation because we are writing chemical reaction in the form of word. In the form of word. So this becomes word equation. And now here I am writing symbol of carbon, that is C. Symbol of oxygen, that is O2 as a molecule. Mind you one thing, writing chemical equation, writing a chemical equation, we use molecules. We use molecules. Okay, we will not use atomic form because atoms are unstable. Atoms are unstable. So we do not use atoms while writing chemical equation. We use molecular form while writing chemical equation. If it is element, then we write molecule of that element. And if it is a compound, then we write its molecular formula. Okay? So we do not write atomic form. Why? Because atoms are unstable. Atoms are unstable. So carbon is a monoatomic element. Monoatomic element. So its molecule has only one atom. Its molecule has one atom. So I am writing C only. Here O2. Why? Because oxygen is diatomic element. Diatomic element. And what are diatomic elements? Elements which have two atoms in its molecule. Element which have two atoms in its molecule is diatomic element. So oxygen being a diatomic element, it exists in nature. How it exists in nature, that we write in the chemical equation. So it exists in nature in the form of oxygen molecule, not in the form of oxygen atom. So oxygen molecule O2. On heating gives CO2, carbon dioxide. Carbon dioxide. So carbon valency 4, oxygen valency 2. If I have to do like this, see. Carbon valency is 4, oxygen valency is 2. Then it can be, then you do crisscross. Then you will be getting, in the next step you will be getting C2O4. Yes, then you can cancel 2 1s are 2, 2 2s are 4. So what you will be getting? C1O2. And we ignore this one, so it becomes CO2. It becomes CO2. So we get carbon dioxide. So while writing chemical equation, the thing that we learned in the previous class, that is how to write chemical formula, that is required while writing product. That is required while writing product. Yes, so carbon plus oxygen on heating gives carbon dioxide. So this is very lengthy way. This is very lengthy way, and this is a very short and precise way of writing, expressing chemical reaction. By this we'll come to know about the number of atoms in the molecule and the number of different atoms present in the product. That what we'll come to know. Yes, so chemical equation is very much precise way of writing chemical reaction. Then the steps involved in writing a chemical equation. So for writing chemical equation, there are many steps we need to follow. There are many steps we need to follow. For writing chemical equation, there are many steps that we need to follow. First of all, first step number 1, write the symbols or the formulae of the reactants on the left hand side with a positive sign between them if more than one. So you have to write the symbols of the reactants. Write the symbols of the formulae of the reactants. whatever you are going to react. For example, just before this we did carbon plus oxygen. So this carbon plus oxygen, carbon and oxygen are reactants. Carbon and oxygen are reactants because they are reacting to form a product. They are reacting. They are undergoing chemical change. They are undergoing chemical change to make a new substance. To make a new substance. So this carbon and oxygen are reactants and carbon dioxide is a product. So in chemical equation, while writing a chemical equation, the first step what we do is we'll write symbols or formulae of the reactants that is taking part in the chemical reaction. And if there are more than one reactant, we put plus. Let's go here again. See here, there are two reactants. How many reactants? Two reactants. So how are we separating these two reactants? By plus sign. So if there are more than one reactant, then we put plus in between the reactants. Then number 2, write the symbols or the formulae of the products on the right hand side with a positive sign between them. Yes. So again, same thing we'll do for product also. But this time we write the product on the right hand side. And if the products are more than one, then we put plus in between the products. Same thing we'll do for reactant as well as product. If one reactant, okay, don't put plus. If one product, don't put plus. If there are more than one reactant, put plus. If there are more than one product, then also put plus. Otherwise, no need. Okay. So this is step number 2. Then step number 3, put the sign of an arrow in between the reactants and the products. So what you do? Put the sign of an arrow in between the reactants and the products. As you can see here, we are putting arrow in between the reactants and the product. So step number 3 is also clear. Step number 1, what we'll do? We'll write reactant on the left hand side. Okay, and if the reactant is more than one, then we put plus in between the reactants. Then product also same thing we do. If it is one product, then we write simply the product. If there are more than one product, then we write plus in between the products. Then we separate this reactant from product by using arrow in between the reactants and products like this. Step number 3 clear. Then step number 4, represent the reactants and the products in their molecular forms, because atomic forms are usually neither stable nor capable of independent existence. So just before this I said you, while writing chemical equation we emphasize on writing molecular forms, because atomic forms are usually neither stable, they are not stable. Atomic forms may or may not be stable, and they do not exist independently. They have no independent existence. This is the reason why while writing chemical equation we write molecular formula and not the atomic form. So reaction, consider following chemical reactions. Now number 1, reaction of lead monoxide with carbon to form lead and carbon monoxide. Reaction of lead monoxide with carbon to form lead and carbon monoxide. So lead monoxide, lead monoxide plus carbon. These are reactants. How many reactants are here? 2 reactants. That's why I am putting plus in between. 2 reactants, that's why plus. One reactant is lead monoxide, another is carbon. These two are reacting, these two are undergoing a chemical change. And this is the arrow which separates. That means left hand side of this arrow reactants, right hand side of this arrow products. Yes? So these are reactants, and there are two reactants, that's why there is plus. And there are two products, that's why there is plus. So lead monoxide reacts with carbon. Lead monoxide undergoes a chemical change with carbon to produce lead plus carbon monoxide. To produce lead plus carbon monoxide. Then this is word equation. What is this? This is word equation. This is word equation. Word equation, because I am expressing this chemical reaction in the form of word. So this is word equation. And then this word equation can be expressed in the form of formulae or symbols to convert it into a chemical equation. So Pb for lead monoxide, mono means one, oxygen, so PbO is the formula, chemical formula for lead monoxide. Lead monoxide. Then carbon C, lead Pb, then carbon monoxide CO. Carbon monoxide, what is the chemical formula of carbon monoxide? CO. So this is chemical equation, and directly when we are expressing word equation into chemical equation, word equation directly into chemical equation, then that is said as skeletal equation. Skeletal equation. Okay, so this is the way how we write chemical equations, following 4 steps. Number 1 was write reactants on the left hand side. If reactant is more than 1, put plus. Write product on the right hand side. If there are 2 or more than one product, then put plus. Step number 2 done. Put arrow in between product and reactants and products. Step number 3 is done. Then what is step number 4? Write the reactants and the products in the molecular form. So we are writing the reactants and the product in their molecular form. So step number 4 also complete. This is the way how we write chemical equation. Then you can see here another reaction. So what is happening here? Let's see. Hydrogen plus chlorine. Hydrogen plus chlorine gives hydrogen chloride. Hydrogen plus chlorine gives hydrogen chloride. So you can see here, hydrogen plus chlorine gives hydrogen chloride. This becomes your word equation. This becomes your word equation because I am expressing the chemical reaction in the form of word. So it becomes word equation. Then, in order to write chemical equation, I have to write it in the form of molecules, it in the form of symbols, formula. So hydrogen is diatomic. I cannot write H. Can I write H? H plus Cl. Can I write? No, I cannot write. Because H, in nature, hydrogen does not exist in the form of atom. In nature, hydrogen exists in the form of molecule. Hydrogen exists independently in the form of molecule, not in the form of atom. So I cannot write H because it is diatomic element. It does not exist in the form of H in nature. So it exists in the form of H2 in nature. Hydrogen molecule H2. We do not write hydrogen atom H. We write hydrogen molecule H2 while writing chemical equation. So H2 plus Cl2. H2 plus Cl2. H2 plus Cl2 gives HCl. Gives HCl. And this is called skeleton equation. This is called skeleton equation. Why this is called skeleton equation? Because whatever is the word equation, I am directly expressing it into the form of chemical equation. So chemical equation again are of two types. skeletal equation or unbalanced equation and balanced equation. Skeletal equation is also called unbalanced equation because generally skeletal equations are unbalanced. Sometimes directly also it is balanced. So skeletal equation can be balanced also, can be unbalanced also, but generally skeletal equations are unbalanced. So then what are skeletal equations? What are skeletal equations? Equations which is an unbalanced one and it is the direct symbolic expression of what equation is skeletal. That means skeletal equation is the direct expression of what equation into symbolic form. What equation into symbolic form. So that becomes symbolic skeletal equation. So H2 plus Cl2 gives a skeletal equation. And I said you chemical equations are two types, balanced and unbalanced. Balanced equation and unbalanced equation. So what do you think, this is balanced or unbalanced? If number of atoms of particular molecule or particular element on the left hand side is equal to number of atoms of that element in right hand side is same, then they are said to be balanced. If number of atoms of the particular element on both the sides are not equal, then they are not said to be balanced. So here you can see H2 plus Cl2. How many atoms of hydrogen are here? 2. And here 1. So not balanced. How many atoms of chlorine are here? 2. And here 1. Not balanced. That means it is unbalanced equation. So this becomes unbalanced equation because number of atoms of hydrogen and chlorine on the left hand side is not equal to the number of hydrogen and chlorine atom on the right hand side. That means balancing a chemical equation, we count the number of atoms of each element on both the sides. If they are same, they are balanced. If they are not same, unbalanced. And if they are not balanced, then we have to balance it. We have to balance it. So note, we cannot write the equation as H plus Cl gives HCl. Can we write like this? No, because H and Cl represent the atoms of hydrogen and chlorine, which have no independent existence. So if we write H and Cl, they do not have independent existence because that means this hydrogen and chlorine means atoms of hydrogen and chlorine, and which does not exist independently. The two reactants should be written as H2 and Cl2. So how do we write the reactants then properly? H2 and Cl2. In their molecular form, molecules have independent existence. So while writing chemical equation, don't forget this. Don't forget this. While writing chemical equation, don't forget this. Molecules have independent existence. That's why we write molecules while writing chemical equation. Don't write atomic form in chemical equation because atoms generally do not exist independently. In this reaction, the numbers of hydrogen and chlorine atoms on the left hand side are not equal to their numbers on the right hand side. Such an equation is an unbalanced one and it is known as skeletal equation. Actually it is TAL, skeletal. So make correction in your book also. Skeletal equation. Skeletal, this is correct, not skeleton. It is skeletal equation. So skeletal equation is unbalanced equation, but sometimes skeletal equations are balanced. So generally they are unbalanced. Okay, you can see some more examples of skeletal equations. Some more examples of skeletal equations. So why these equations are skeletal equations? You can see here hydrogen H2, oxygen O2. Two reactants, so plus. Two reactants, so plus. Now you cannot say this is word equation. This is not word equation. This is chemical equation itself. So skeletal equation is a chemical equation. It's not a word equation. It's a chemical equation. We are writing it in the form of symbols and formulae. So it is chemical equation, no word equation. Okay. And we are writing this by separating two reactants by plus, one product, so no need of plus. We are separating reactant and products by using arrow. So H2 plus O2 gives H2O. Now this is a correct chemical equation. Correct chemical equation. Had we write this H, had we write H plus O gives H2O, this would be wrong. This would be wrong because H, atom of hydrogen, O, atom of oxygen. They do not have independent existence. So how do they exist independently? In the form of H2 plus O2. H2 plus O2. Then only it will be correct. So don't forget this thing while writing chemical equation. Always write molecular form. Always write molecular form. So H2 plus O2 gives H2O, and this is skeletal equation. Why? Because number of hydrogen here is 2, number of oxygen here is 2. That means on the left hand side, number of hydrogen is 2. On the right hand side, number of hydrogen is 2. Balanced, same, equal number. Oxygen on the left hand side 2. Oxygen on the right hand side is 1. So unbalanced. So number of oxygen atom on the left hand side is not equal to number of hydrogen atom on the right hand side. Hence it is not balanced. So it is skeletal equation. It is a skeletal equation. Here also Mg plus O2. Now you must be thinking, okay, Mg is also atom. Mg is also atom, and it is correct. Yes. All metals are monoatomic element. Their molecules also have one atom only. Okay. Monoatomic element means their molecule can have only one atom. Their molecule can have only one atom. So Mg means one atom as well as one molecule. So Mg independently, when you are writing symbol independently, magnesium Mg, then that becomes atom. But whenever you are writing in chemical equation, it means atom as well as molecule. Atom as well as molecule, because monoatomic element will have one atom in their molecule. One atom in their molecule. This is diatomic, that's why I am writing O2. Diatomic, so O2. So Mg plus O2 gives MgO. Now why this is skeletal? Why this is unbalanced? Magnesium 1, magnesium 1, oxygen 2, oxygen 1. That means number of oxygen is not equal. So it is unbalanced. Again, N2. So why nitrogen 2? Because it is diatomic element. So it exists in the form of nature as N2. Diatomic. Plus H2, this is also diatomic. N1 here, N2 not balanced. Hydrogen 3, hydrogen 2 not balanced. That's why it is unbalanced, and hence it is skeletal equation. Then Na plus Cl2 gives NaCl. This is also skeletal because Na1, Na1. Why Na is 1 only, no 2? Why here is no 2? Why we cannot write like this Na2? Why? Because sodium is a metal and all metals are monoatomic element. That means their molecule contain only one atom. Their molecule contain only one atom. So Na plus Cl2 gives NaCl, gives NaCl. Na1, Na1. Cl2, Cl1. So this is not balanced because number of chlorine on left hand side is not equal to number of chlorine atom on the right hand side.